Okay, a second type of exercise that you guys must know is how to graph a logarithmic function by using transformations. So let's get all the basic properties of these functions by using, let's start with the Desmos calculator right here, and graph, and then we're basically just gonna go and complete this table in your class notes with basically what we find out. So we're gonna start by graphing these functions. Here you're gonna see the pictures on the right hand side. And so let me graph, notice here I'm graphing the logarithmic function with base 2. Okay, this is a blue graph going up as you move from left to right. Now let us graph the logarithmic function, the base is 3. See, have another, this is the graph for this function. And when you guys graph this last function, base 1.5, notice that they all go, as you go from left to right, they all go, the increase. Okay, and basically what they have in common is that all these bases are bigger than 1. So that's something you guys want to remember. Now if you graph a logarithmic function that has base, in this case 1/2, here's the graph, is going down, or logarithmic function with base 0.6, then when they have bases less than 1, you can see their pictures and they're decreasing, and they all pass, all these logarithmic functions, these basic functions, pass through the x-intercept 1, 0. Second property they also want you to know is this x equals 0 is basically a vertical asymptote for these basic functions. Okay, they don't go beyond this line. Okay, and you can also see from this picture that the domain for these functions is from 0 to infinity. Okay, but you can also see that the range is from negative infinity to infinity. Okay, now let's go and hide these functions and do some special transformations. Okay, in this case let me go to the bottom. Okay, so this is a general member of the family of logarithmic functions. In this case, for different values of h and k, you have these functions. So right here, the one that you're seeing is when h is 0 and when k is 0. So this is basically the function log of x. Okay, now let me show you what happens. Here's a vertical asymptote. Okay, now if I let h be in this case 1, okay, notice the graph move, it went to the right 1 unit, and also the vertical asymptote shifted 1 unit to the right. Okay, so this asymptote changes with the horizontal shifting. Okay, now notice here this x-intercept 2,1. Okay, when I change the k value, okay, say to k1, okay, what basically happened is this graph used to pass through this point 2,1, and it went up 1 unit to 2,1. And so when you guys do transformations of logarithmic functions, something you want to remember is that the number away from log, away from x, is vertical shifting, and that's a k value. So let me run this graph based on different k values. Notice that as k changes, the graph goes up and down. Okay, let me stop it right here. And if you guys change h, notice as h changes to different numbers, the vertical asymptote also changes. Okay, and a shortcut that you guys want to remember is that every time you have to graph these logarithmic functions by using transformations, notice that the vertical asymptote is this h value next to x. Okay, So that's something you guys want to remember for the next test. So let's go back and fill out the table with all these basic properties. Okay. So we notice when a is a number bigger than, when the base is bigger than 1, then our function increases. These basic functions go up from left to right. When a is less than 1, then the function decreases. Okay, so an increasing function looks like this, and then a decreasing function looks like this. Okay, one point that you guys want to remember for this logarithmic functions is x-intercept, so they all pass through 1 comma 0. And a second point of interest that you guys want to remember is every time you plug in the base into x in these functions, then the output is always 1. So for example, when you guys plug in, if you have the base 2 and you plug in 2, then the y value will be 1. Okay, so that's a property you guys want to remember. And then the vertical asymptote is for this basic function, it's going to be x equals 0. The domain is from 0 to infinity, and the range is from negative infinity to positive infinity. But something you guys, let me give you guys a math secret. When they ask you to use transformations, then you want to remember that the vertical asymptote for, suppose you're looking for something like this. Let me remove this. So when they ask you to graph a function that has been shifted h units horizontally and k units vertically, then the vertical asymptote is always x equals h. So you guys want to keep this in mind, okay, as you guys graph these transformations.